So this is lesson 1.4 in intermediate algebra, and we're on page number 44. We're going to talk about exponents and then just a little bit into scientific notation here. So let's get started with, first of all, just a reminder of what an exponent is. An exponent is that little number called a superscript, which means above the writing, and that's what that 3 is. This x here is called the base. So if you remember, what that means is it's basically a shortcut to writing this, x times x times x. So instead of writing that out, we just write x to the 3rd power. Same is true with 2 to the 6th power. Instead of writing 2 times 2 times 2 all the way 6 times, we just write that. It's just a shortcut method, which math has a tendency to do a lot of multiplication. So what we're going to do is we're going to look at something like x times x to the 4th. This is the first example. And what we're doing here is we're multiplying those. So if we were to write this out in long form, it would be x times x, which is x cubed, times, which is this x times x times x times x. And when I multiply those, I get 7 x's that I'm multiplying. So it looks like that, x to the 7th power, which when you look at this over here, it can be written a lot quicker as x to the 7th because we do x to the 3 plus 4 equals x to the 7th. So that's what you do when your base numbers or letters are the same, is you add the exponents together. So for example, if I had y to the 4th times x to the 3rd, I cannot combine these because, like I said just a minute ago, my base numbers or letters are not the same. So all I can do with this is to rewrite it without the multiplication sign, and that is as simplified as I can get. So the only way you can do this adding the exponents is if the base number is the same. And there you go. All right, so that is the first property for exponents, top of page 45. There's a second property, and that second property is called the power rule. The book doesn't really say anything about it being the power rule, but what it says is that when we have any number or letter, so let's use the number 3, and let me get me a better 3 on here. So there's a better 3, and I have it squared, but then I also have a parenthesis, and let's say I take that to the 4th power. So what that means is we're going to take that 3 times 3 and do it 4 times. So we've got 1, 2, 3, 4. So how many 8 or 3s do I have there? I have 8 3s. So that actually equals 3 to the 8th power, which is what 4 times 2 is. So that's the power rule, or that's the property 2 for exponents. If we have a letter or a number, and we have an exponent on it, and we have an exponent on that, that actually means x to the 2 times 3 equals x to the 6th power. So that's property number 2. All right, let's keep going. Property number 3 says that if we have something like 3x to the 4th power, that means everything inside those parentheses are going to be taken to the 4th power. So 3 to the 4th power and x to the 4th power. So when we take 3 to the 4th power, we get 3 times 3 is 9, times 3 is 27, times 3 is 81. X to the 4th power ends up being our answer. So this 4 here is put on each piece inside that parenthesis there. So that's the property 3 for exponents. So let's look at a couple of examples, top of page 46. We've got negative 3x squared. And we are multiplying that times 5x to the 4th power. Now this is basically going to be, you're going to take the numbers that are inside the parentheses, because you can always multiply numbers times each other, and we get negative 15 when we multiply a positive times a negative. Then we're going to look at my x squared and my x to the 4th. I can combine those because they're the same variable. And what do? I add the exponents. So I get, when I add 2 plus 4, I get 6 there for an answer. So not too terribly complex, but let's do some that are a little bit more so. Negative 2x squared, and we're going to cube that. And then we're going to take 4x to the 5th. So notice there's a cube here, so we're going to cube everything inside the parentheses. So negative 2 cubed, because there's an odd number for the exponent. When I take negative 2 and I cube it, because that 3 is odd, I know I'm going to get a negative answer. So 2 times 2 times 2 is 4. And because the 3 is odd, I'm going to get a negative 8. And then when I've got my x here, what does that say? That says I'm going to multiply those two, because I'm cubing an x squared. And then I've got my 4x to the 5th. Now I can take the parenthesis off because there's no number up here, no exponent at all. So I'm not doing anything to the 4 or the x. Then I've got a number here and a number here that I'm multiplying, and a negative times a positive gives me negative 32, and a 6 and a 5, and I'm going to add those together and get the 11. Now, some students try to figure out how in the world they can remember when they add and when they multiply. Well, there's the key. When the exponents are on the same level, you add. When the exponents are on a different level, this 3 is higher than the 2, then you multiply. And that's just a little clue that when you're going, that you automatically know what to do. All right, let's look at example number 6. We've got x squared, and it's taken to the 4th power. I have x squared, y cubed, and it's taken to the 2nd power. And then I have y to the 4th cubed. Now notice that each one of these pieces here has my exponents at different levels. So that means I'm going to multiply. And I'm going to look at each one of these. So I'm going to multiply the x squared times 2 and the y cubed times 2. And then my y 4th, I'm going to multiply by 3 and get 12. So now I'm going to look at these two, because they both have the same base. They both have x's. Notice the 8 and the 4 are on the same level, so I'm going to add them. Then I'm going to look at these two, and they both have the same base of y, and the 6 and 12 are on the same level. And I'm going to put them together like that. And because this is an x and this is a y, I cannot combine those, so that's as far as I can go. Bringing us to property 4 for exponents. Now this one is a little bit tricky, and I've seen math teachers teach this incorrectly before, so hopefully I can do this without confusing you. So 5 to the negative power. All right, one of the things that's very important as far as negatives oftentimes, and again in this case, show position. If you remember a while back when we were doing the number line, I was always telling you that positive went this way and negative went that way. So it shows the position of the number compared to the zero. The positions to the left of the zero are negative numbers. It's pretty much the same kind of an idea when we're looking at exponents with the negatives. What it's saying is that this 2 and this 5 are in the wrong position. You can write it like this, 5 to the negative 2, knowing that that 5 and the 2 are in the wrong position. So what is the right position? Well, like we've said before, every number can be written as a fraction. So what this negative is saying is that 5 and 2 are in the numerator position now, but the proper place for them is in the denominator position. Okay? Now, some people will look at this and say, oh, all you did was flipped it over and it made it 5 squared. No, I did not flip it over. I moved it to a different position. So let me give you an example of what I mean when I say it is not flipped over. Okay. So according to what I had said before, the negative means that the 5 and the 2 are in the wrong position. They do not belong in the denominator position. They belong in the numerator. Notice what I have in the numerator. This is not a negative, so that means the 3 squared is in the correct position. So it'll stay there, but this will move up. Okay, see what happened there? Because this is not a negative, it does not move. Some people would like to tell you that this turns into this, but it doesn't because there's no negative in front of that 2 in the top one. So something to remember when you're doing that. It's very important to remember that, or you will get wrong answers down the road when we get into more detail of actually using these negative exponents. So again, this says that this is in the wrong position. So what I'm going to do is I'm going to put the 1 on top because there has to be a number on top. So if we take this here and move it to the bottom of what? I mean, there has to be a number on top, and it's always going to be an assumed 1. So I'm going to move that negative 2 down there, and this is very important. What did I move down? I moved the negative 2 down, and I moved the exponent down, and the exponent changes to a positive. So that gives me 1 over negative 2 times negative 2 times negative 2, an odd number of exponent, which means my answer is going to be negative, and I just take 2 to the 3rd power, and I get that. Now this is also equal to negative 1 over 8, or negative, or that. All 3 of these answers are the same thing, so it doesn't matter which of the 3 you choose to use. Okay, let's look at the next one, 3/4. And this is to the negative 2 power. All right, so what is being taken to the negative 2 power? Both the 3 and the 4, because they're both in the parentheses, so this is the exponent on both parentheses. Now, if that's the case, this is property 5, whenever you have an exponent with a fraction, each part of the fraction, the numerator and the denominator, get that exponent. All right, so what this is telling me now is that this 3 squared is in the wrong place. This 4 squared is in the wrong place. So in order to write this correctly, I have to bring the 4 squared on top and 3 squared on the bottom so that they're in the right position. Now I can take this and write it as 16 over 9. So one of the things that's very, very important, you cannot use an exponent on a base number if it's negative. I mean, what is 3 squared? 9. What is 3 to the minus 2 power? I mean, 3 times itself, how many times? I mean, -2, you can't do that because it's not 3 times -2. It's 3 to the -2 power. So again, all this negative does is tells you it's in the wrong position. So before you can solve it, you have to make that negative a positive. All right, so let's go into some division here. So for instance, if we have a base number of 6 and it has an exponent of 3 and it's over 6 with an exponent of 2, how do I solve that? They're both in the right position because they're both positive. So the mathematical way to do that is to write the base number and to write the top number minus the bottom number. And that gives me 6 to the first power, which equals 6. So if you wanted to work this all out and take 6 times 6 times 6, and then did that over 6 times 6, which is 32, you would get, when you divide these two out, you would get 6. But this is just a lot quicker and easier way to do that. So, for instance, if I had 2 to the 8th power over 2 cubed, that's going to be 2 to the 8 minus 3, which is 2 to the 5th power, and then you can solve that from there, which is going to give you 32. So what if I have x squared over x to the 18th power? This is example 10, the second part of example 10. Well, that equals x to the 2 minus 18. Always the top number minus the bottom number. Numerator minus the denominator. And that gives me x to the negative 16. Now, sometimes I'll leave it that way. Other times I'll say, you know what, I need a positive exponent there so I can actually work with it. So even though this is x to the negative 16 over 1, I need to put it in the correct position, which would be 1 over x to the 16th. And that would be the correct answer if the book is wanting you to give that to me with positive exponents. Do a couple more examples, then jump over to 1.4b as in boy video. So let's look at a to the 6th over a to the minus 8. And again, that says a to the 6th power minus this negative 8. Don't forget to subtract the minus 8. Now remember, when we have two negatives, they both turn to positive, and that gives me a to the 14th power. Let's do the same with an m. Now remember that you can only do this when the base number or letter is the same. So this is m to the minus 5 minus, because it's division, a negative 7. So these two change to positive. So m to the negative 5 plus 7. Signs are different. You take the difference between the two and put the sign of the largest number on there, and you get m squared. Okay, so I'm going to go ahead and stop this video and start with 1.4b.